Hello guys, welcome to the Innovation Lab. In this video we're going to be conducting a spec review and functional test on this DC to DC boost converter. This is a different DC to DC boost converter that we have not tested before. This boost converter is rated for 900 watts of output power, and it has an input voltage range of 8 to 60 volts and an output voltage range of 10 to 120 volts. Yeah, so we are very excited to test this converter and to see exactly how it's gonna perform. So one of the things I like about it is that as you guys can see here, it actually comes with digital controls instead of the small potentiometers that are kind of hard to adjust using small screwdrivers. So yeah, we're really gonna have some fun with this converter, and the plan is to really push it to the limit. So as most of you guys know, when they rate these converters at specified output power, you can only get that amount of power if you use the maximum input voltage, in this case, which is the 60 volts. So our plan is to apply 60 volts at the input of this converter and see if we can come close to 900 watts. And luckily for us, we have a bunch of 12 volt lead acid batteries here that we can use to generate the pure DC 60 volts that we're going to be using for this testing. Yeah, as a lot of you guys have seen in our previous videos, so we have done a lot of testing using this DC to DC boost converter model, which is very cheap and affordable and also very nicely packaged. So I have done a lot of testing on this boost converter, showing how you can use it for different applications, battery charging and different kinds of things. But then I came across this one here and I wanted to give it a try. So the plan for this video is to take the time to really explore this converter and to make sure that we have covered all the key functions of the converter that I believe that you guys will be interested in. And if we miss anything, don't forget to leave us a comment and we'll try to cover that in a future video. Alright guys, so looking at all the tests and the spec review that we're hoping to conduct on this DC to DC boost converter, so this video could possibly get slightly longer than our usual videos, but our plan is to present the video to you guys in sections, such that if you're in a hurry or if there is a specific section that you are more interested in, you can skip through the video to get to that section, and you can also save this video for future reference if you are doing some more designs or more testing on your converter. Alright, so what we're hoping to do in this video is to capture the respective sections and to kind of move things around a little bit to keep it fun and interesting. Alright guys, that's it in a nutshell. This is what to expect as we're going into the video, and I hope you guys will have fun watching this video. Alright my friends, let's get started. Alright guys, here is the setup for the initial power on testing that we're going to be conducting on this DC to DC boost converter. So let's go ahead and look at what we have here. So looking at the input side of the setup, as you guys can see here, we have our digital power monitor, and we're going to be using this to monitor what's going into the converter from our battery system. So it's going to be able to tell us the input voltage, input current, and the input power that is going into our boost converter. And that's kind of why I like using this power monitor, because it gives me everything I need all in one screen. Also, to supplement or to check the numbers or readings that we're getting on the power monitor, we have our Fluke digital multimeter here. The Fluke DMM is connected in parallel to the power monitor, as you guys can see it here. And down here we have our current probe, which again we're going to use to double check the current measurements that we're measuring using our digital power monitor. Now on the output side, we have another digital power monitor, which is the same exact monitor, but here we're going to be monitoring the output voltage and the output current and output power going to our load. All right. So here, as I mentioned, the plan is to run this entire test with pure DC. And what I mean by when I say pure DC is power from our battery pack, power with no ripples, because we don't want to make excuses and say maybe the boost converter did not perform well because there's some, a lot of ripple noise at the input. And that could be something we get when we use a switch mode power supply like the power rack that we're looking at here. So the plan is to conduct all the testing using battery packs. And luckily enough for us, we have enough battery units here to give us all the input voltage variations that we're gonna need. 12 volts, 24 volts, possibly 36 volts and 60 volts. Maybe if we have time, we can squeeze in 48 volts to see how it behaves. All right, guys, let's go ahead and bring in the power and get right to it. Alright guys, for the initial power on test, we're going to be using our 12 volt lithium phosphate battery pack. And as you can see here, this battery pack gives us 13.23 volts, which is what we have going into our DC to DC boost converter. And the plan is to step that up to 18 volts. So if we enable the output, you will see it here. So right now we have the output set to 18 volts, and it's going to be able to drive up to 15 amps of current when we apply a load. And for this initial testing, we're going to be using a 30 watt light bulb. And what we're trying to do here is to show that this converter can maintain output regulation given the small load that we have on it. All right, let's go ahead and connect the light bulb and we enable the output. All right, guys, as you can see here, we have connected the light bulb. So one thing I realized about this converter was that if you look at these controls, they made it seem like it comes with an output enable switch, which is this push button switch here. So realistically, what I'm finding out is that this is more like a boost mode enable switch, because as you guys can see here, the output voltage that we're applying to our load is essentially the same input voltage that is coming in minus some voltage drop because of the applied load. And now when we go ahead and enable the boost mode by pressing this button, so what you see is that the output will slowly rise, as you can see. So this converter has some kind of a soft start function, which I don't know, depending on what you're doing with the converter. I don't think it is desirable for me. Yeah, so as you guys can see, now when we go ahead and disable the output, as you can see here, the output dropped down to 12 volts, but it didn't quite go off entirely. So if I call that an output enable, that will be very deceiving. So let's just go with the boost enable switch. Yeah, as you can see here, with the boost mode enabled, the output slowly ramped up again to about 17.8 volts. And when we disable it, as you can see, it dropped down to the input voltage level. And we do that again. So there is a soft start. As you can see, the voltage rise up. Alright guys, we have seen that at least the boost converter works. We had it set to 18 volts with some load applied. I think it was about 55 watts of load. So we were able to maintain that voltage with a reasonable margin. And let's go ahead and actually look at the efficiency. So we enable the output again. So we are at 17.8 volts. We had about 0.2 volt drop. We are measuring an output load of 55 watts. So let's look at the input. So at the input we have an input power draw of 62.2 watts. So when we do the math, we can kind of figure out what the efficiency number will be for this test. Alright guys, let's go ahead and look at the spec review for this converter, and after that we're gonna do more testing on it. Alright guys, before we go into doing some actual testing on this unit, so let's go ahead and look at the specs on Amazon. Alright, so this converter, as you guys can see here, this is basically the description of the converter. So it can take in an input voltage range of 8 to 60 volts and an output voltage range of 10 to 120 volts DC. And the maximum output current rating is 15 amps, maximum output power rating of 900 watts. And as we know from all the previous converters that we have reviewed, you can only get this power output if you're using the maximum input voltage, in this case, which is 60 volts. Alright, so looking at the converter, let's kind of look at the features, see what it has. Yeah, this is a really nice design. So one of the things that it has is it comes with actual digital controls, which I think is really nice. So that allows you to adjust your output voltage and output current, and when you have selected a value, you can just go ahead and set it. And as you guys can see, it also comes with this small display here that you guys can use to visually look at your settings as you're doing that. The cool thing with this is that it doesn't come with small tiny little potentiometers that's actually hard to get to. So yeah, so we're gonna kind of look at this to see how it's gonna perform. Alright, let's look at more description, kind of what I've already mentioned. It comes with this LED digital display here, and it also comes with the push button digital control switches here, LED indicators on this side to show you, I think it's when you're in a CV mode, which is constant voltage mode, and constant current mode, which is your CC, and the red LED kind of shows you when you have an output. So here on the right, you have your output positive, output negative connectors here. And here you have your, on the left, you have your input positive, input negative. So, and as you guys can see here, in the back here is your power inductor. Yeah, alright. For some reason, this converter comes with two shunts. one at the input side of the converter and one on the output side of the converter. I guess we'll kind of see how all of this will perform and what kind of role they're going to play. And we have a 20 amp fuse at the input, and we have our input filter cap, output filter caps. And I believe that's it for this. The rest is kind of like the dimensions. It's a pretty compact board for 900 watts. So we will see how the whole thing is gonna perform. Yeah, looking at the back side of it, and it also comes with a fan. Looking at the back side of it, it's a really neat build. I am impressed with the PCB layout. The one thing I have not seen here is the rated efficiency of the converter. Usually they try to add it in the description or down here. I am not seeing it, so I guess we will find out what the efficiencies might be at the different input voltages and output loads. And I believe this manufacturer actually makes a few different options as well. So pretty much that's it for this converter. One thing I haven't covered is the price. So this unit, you can get it for about $29, almost $30 on Amazon. I don't know how much you can buy it from eBay. And a lot of this, if you have the patience to kind of wait, you can get it for cheaper if you buy it from like online or any of those sources. But I don't have the time, so I bought it from Amazon. So the tricky part for me, it took me a while to figure out how this control system works. And if you guys are thinking of using this converter, you might want to pay attention to how to set the output voltage and the output current using these digital controls right here. So the very first adjustment mode that we're going to look at is the voltage adjustment. So this digital control is supposed to allow you to be able to control or make adjustments to the output current and output voltage. So what I realized while I was trying to learn how this works was that they actually built in a lot of safety into this, such that when you go into the voltage mode, it disables the output to allow you to adjust to the voltage level that you want. Right now we are at 34 volts, as you guys can see, and the output is off. So, and how you know is if you look at our power monitor here, so essentially it shows us that when the output of the boost converter is off, what you'll be getting at the output is the same voltage level as your input voltage. And this is kind of a basic behavior of a boost converter. So let's go ahead and see what happens when we enable the output. So we have the output voltage set to 34 volts. So if we enable it by pressing on the OK button, this push button here, so we go ahead and enable that. And when you enable it, you see the red LED that says out. That's your indication that now you're supposed to have an output. All right, so let's come over here and see what we're looking at. So now we have 33.9 volts, which is approximately 34 volts at the output of this converter. All right, now for the current adjustment, and we're not going to be able to verify the current adjustment until we put a load on this. So we go back to setting, and the output goes off, as you see. So the next one, you see the last digits of the LED that you see there, the last segment of the LED that you see there, it says A, which shows you that now we are in a current mode. Obviously A stands for amperes, as you guys know. So this allows you to go up and down as you want. If you press and hold, as you would expect, it just goes automatic by itself. And when you're done, press OK. So now what this shows you is that your output is set at 2.8 amps at 34 volts. And this is what you should expect if everything works as we expect on this converter. So this is really, really awesome. I love it. So, and the same that I was showing goes to the voltage. So now we're in voltage mode. Alright guys, let's go ahead and make some output voltage adjustments. So right now we're at almost at the input voltage level. We're already in the output voltage mode. So let's increase it, and we should be able to get to 120 volts as advertised on this converter. It really takes a while to get there. You just gotta be patient. Alright, as you can see, we got to exactly 120 volts as the converter manufacturers advertised. So right now, let's take it all the way down to the input voltage level. What I realized earlier was that as you're going down, this converter actually wants to go almost to zero. That doesn't mean that it's going to go below the input voltage level. It just means that, I don't know if I'll call it kind of a design flaw. Alright, so this is what I was talking about. Right now our input voltage is at 13.3 volts. So if you hold on to this, it's just going to keep going. Let's see exactly how low it's going to go. Alright, so it's going to go all the way down to zero. It really shouldn't do this because this could be misleading, but then we are at 0 volts. So when we go ahead and enable the output, so let's see what we're getting on the output. Alright, so I'm not exactly sure what's going on. So when you go all the way down to 0 and you enable the output, it seems that the converter defaults to about 56.4 volts. I am not exactly sure what's going on, why it is doing that, but well, as you guys now know, as a safety precaution, try not to go below your input voltage. That's all I can say for this. So let's see if we can actually correct that by going back up to above the input voltage. So our target, let's choose a target of 14 to 15 volts. All right. Amazing. So right now we're exactly at 15 volts. All right, so let's go ahead and enable the output. All right, as you can see, all it takes is for you to exceed the input voltage rating, and the output voltage regulation comes back as expected. So we had it set to 15 volts and we're measuring 14.9, and here you can see we're at 15 volts precisely. Alright guys, that's it for the output adjustments or digital control. So the next thing we're going to do is to put a load on the system to look at the output voltage regulation. Alright guys, so here is the setup for the load testing that we're going to be conducting on this boost converter. And our plan here is to apply multiple input voltage levels. So we're going to be using 12 volts, 24 volts, 48 volts, and finally we're going to be using 60 volt DC to drive this boost converter. And also the plan is to conduct all the tests at an output voltage level of 120 volts. So you may be wondering why we want to do that. We were only interested in this converter because it promised an output voltage level of 120 volts. Honestly speaking, I have been very satisfied with the performance of these boost converters here, but they have an output voltage limitation of about 90 to 95 volts, I believe. So when I see a converter that can go up to 120 volts DC, it kind of piqued my interest, and I wanted to test it to know if we can use it for high voltage applications like battery charging and all of that. So if this converter does not perform well at 120 volts DC, it kind of defeats the purpose for me there. And I know a lot of you guys too are interested in converters that can give you up to or above 100 volts DC. So that's why we are all interested in this converter. Also, as we're running through the test, we're going to be keeping an eye on the input power and output power, so that way we can calculate the efficiency at a given input voltage level and an applied load. Also, we're going to be keeping an eye on the peak-to-peak output ripple levels at the respective loads. Alright, so let's take a closer look to see exactly what we have here on this setup. So going from the left, we have our 12 volt lithium phosphate battery pack, and we're going to be using the DMM as you can see here, and our digital power monitor as you can see here as well, and also our current clamp to measure all the input power parameters that's going to be going into the boost converter. And on the outputs, we have our power monitor here to show us how much power that is going to our load. So one thing that we added to our test setup will be this load control module or current control module. And the function of this module is to allow us to slowly increase the load that we're going to be applying to our converters, and hopefully we're going to be using this in testing our converters in the future. So the way this works is actually quite simple. So we are just driving this MOSFET in linear mode. So that way it kind of acts as a controllable resistor, because what we are doing is to vary the drain to source resistance by increasing the control voltage that is going to the gate of the MOSFET. Alright, I was not able to capture the build of this device in this video, but if this is something you guys would like to learn about, leave me comments and I will see if I can make a video about it. For the test load, we're going to be using this 500 watts 20 ohm power resistor stack that you guys have seen in the build video. And the reason for building this load stack is that we wanted to have a reasonable load that we can apply at the output of the converter at 120 volts DC. So doing the math, at 120 volt DC and at 900 watts, if you apply Ohm's law, you should need about 16 ohms of load impedance that's going to be applied to the converter. But what I did to even make it easier on the converter was to add an additional 4 ohms, so that way we have 20 ohms. So instead of driving the full power, we're going to be kind of maybe driving less than that, so that way we don't destroy the converter. Alright guys, let's get started. Alright guys, I know that a lot of you guys will see the test that we're conducting, and some people will say that we are probably doing something wrong, that the problem is with the way that we're conducting the test, and that's why we're seeing the massive voltage drop that we're seeing with this converter here. Yeah, so what we're going to do here is to kind of create a comparison in the performance with the known DC to DC boost converter that we have made multiple videos on, that we have been using for a long time. This converter has a very stable output even with as you apply load. So I'm going to use this to show you guys what the expected behavior of a well-regulated boost converter should be like. So here we have a 24 volt input going into our 1500 watts DC to DC boost converter, and the plan is to raise the output voltage of this boost converter to the maximum point. As you can see here, we have already done that. It's at 96.6 volts. So, and we're going to repeat the same load that we used for the previous testing. This is our 500 watt resistor stack. The only thing is that we may not be able to get up to 500 watts if we are using only an output voltage of 96.7 volts. And again, we're going to use our current control device here to slowly raise that output current going to our load. The whole point of this exercise is to see how stable the output of this converter is going to be under load. And that will kind of tell you guys what I was saying about the DROC converter, that the output regulation is not as expected. All right, let's check it out. All right, so right now we are at 240 watts. We're delivering an output current of 2.52 amps to our load. And as you can see, the output is still stable at 96.7, not even shifting. All right, let's try to increase it some more. So right now we are at 346 watts going to the load. And the same thing, we only saw like a 0.1 volt drop. So from 96.7 to 96.6. Yeah, so but the point is that you guys can see the output voltage remained stable, not shifting at all. And this is exactly how a stable converter should perform. Alright guys, now you guys can see when I say that this converter did not perform well with the output voltage regulation, and this kind of affected everything because now we can't even make efficiency measurements because all the values and numbers we're going to get is not going to be accurate. So the final test that we're going to conduct on this converter is to try to use it as a battery charger. And we're hoping that it will perform better with battery charging than it did with resistive loads. So what we have here is very simple. So we have our power rack here, which we have configured to give us a 24 volt output. And we're going to step up that 24 volt to about 30 volts that we need to charge our lithium phosphate battery pack. So as you can see here, right now we have this configured to give us 30 volts at 0.5 amps. We're going to start at 0.5 amps, then we slowly increase the charging current just to make sure that we don't overload the converter. All right, so let's go ahead and enable the boost mode. All right, we have our boost mode enabled. So even though we set it to about 0.5 amps, it went to about 0.97 amps. I guess that could be a good thing. So now let's go ahead and increase the charging current. Actually, I made a mistake in my comments. So this was actually set to 0.79 amps. So let's go ahead and increase that. So I guess we can increase it to about 2 amps. All right, we are at 2.09 amps. We enable the boost mode. All right, guys, as you can see, we are at 2.12 amps going to our battery, and we're delivering about 54 watts going into the battery pack. All right, let's increase it some more. So this time we go to about 5 amps. All right, I believe we're at 5 amps. Boost mode enabled. All right, my friends, so we're getting a very good response with the battery charging. We are getting 5 amps going into our battery, a delivered power of 131 watts going into the battery. That is not too bad. All right, let's push it some more. This time we try to go to about maybe 10 or 11 amps. All right, we are at 11 amps. So boost enable. Alright guys, we got to about 10.9 amps. We're delivering an output power of 203 watts going into our battery pack. That is very impressive comparing it with what we got from the resistive load. So we can try to increase it some more since there is a promise of 15 amps of output current. So let's go to 14 amps. All All right, we are at 14 amps. Boost mode enable. Let's see what we get. That's actually quite impressive. So we got to 13.7 amps with a delivered power of about 372 watts going into the battery pack. Again, that is quite impressive, and I am happy that at least it works better with battery charging. The only thing I am observing is that it seems that this converter only performs better when the voltage differential between the input voltage and the output voltage is not too wide. So for example, in this case, we have 24.4 volts coming in from our power supply, and we only boosted it up to about 30 volts, which is what we are using to charge our battery pack. So the differential is only about 6 volts. So, and I believe that they mentioned this in the actual manual that comes with the converter, which I saw a lot later into the testing, but it wasn't mentioned on the description that they had on Amazon for this converter. So that could be a little bit deceiving there, saying one thing on the actual manual that comes with the converter and saying something else on the description on Amazon. All right, so I am glad that it's actually working for battery charging. And one thing I would do after this video will be to try to use this converter as a solo charger, because I am seeing this soft start behavior. I think it might be favorable for solo charging. It might be nicer to a solar panel. So I'm going to try to use it as a solo charger to see how it performs. And if it performs impressively, I'm going to make a video to show you guys that it could be an alternative, a cheap alternative for solar charging. Alright. So the last thing we can look at here will be the output ripple of the converter while we're using it as a battery charger. So what I'm seeing here is kind of a maximum peak-to-peak ripple of about 230 millivolts. So I don't think that is too bad, you know, considering that this is almost a 30 volt output. So 0.2 volt ripple is not that bad. Alright guys, that's it for this video. I hope you guys had some fun. I hope you guys got some good information about this DC to DC boost converter from this video. So looking at what we've seen in this video, this converter did not perform very well with resistive loads. So what we were actually seeing was that at the maximum rated output voltage, it can only support about 80 to 100 watts or thereabouts, depending on your input voltage. It was later that I saw that they actually mentioned on the datasheet or manual that came with the unit that the converter was not designed to handle a large output to input voltage variation. That means that if your intention is to drive this converter at the maximum rated output voltage, you are probably gonna be disappointed, because what happens is that you're gonna be seeing a whole lot of voltage drop, as they mentioned in the manual. But the deceiving part was what was said in the manual does not correspond with the product description that they had on Amazon. So what they mentioned was that this converter can provide a maximum output voltage of 120 volts, which it did. And they also said that it can support 900 watts of load, which it did not. And they also mentioned that it can support up to 15 amps of output current, which it did if you are using it for battery charging, or if you're using it in an application where the variation or differential between the input voltage and your boosted output voltage is not technically too large. So that could be a little bit misleading, but If you understand it and you think you can use it for something else and it's going to work for you, that would be great. And the things I liked about this converter was that they came with some very nice digital control that makes it easy to work with the converter, and it actually performs well as a battery charger, again, as long as you're not trying to drive it to the maximum voltage. So yeah, so that's it in a nutshell for this review. So what I'm going to do after this video is to try to use it as a solar charger. Something tells me that given all the soft start function that it has, it could potentially work well as a solar battery charger. I don't know yet, so I'm going to try that, and if it works well, I will make a follow-on video to show you guys that. Alright guys, I hope you had fun watching this video, and if you did, don't forget to give us a thumbs up. And if you would like to see all the cool videos and things that we have coming up, subscribe to the Innovation Lab if you're new here. Alright my friends, I will see you guys in the next video.